Every single software project, whether it's big or small, is up against the exact same enemy: complexity. It's this beast that kind of grows in the dark, tangling up your code and slowing everything down. So today, we're going on a hunt. We're going to learn how to tame that monster. This quote from Matt Zanstra's book, PHP Objects, Patterns, and Practice, just perfectly captures the challenge, doesn't it? It's a story every developer knows by heart. You start with a simple idea, a nice clean script, and then, before you know it, you're wrestling with this creature that you yourself created.
So if we're going to defeat this monster, we first have to understand it. In this first part, let's take a look at where all this complexity actually comes from and how a simple little project can grow so powerful that it becomes a real problem.
It always starts small, a simple script to do just one thing, but then you add a feature, and you copy and paste a block of code because, it's fast. Then you do it again. Pretty soon, that simple script is a tangled mess. Duplicated logic means that a bug in one place is actually a bug in 5 places. It becomes fragile. You change one little thing over here, and something totally unrelated breaks over there. This is the monster. And it's the polar opposite of what a modern application should be: organized, efficient, and robust.
So when you get right down to it, we're not fighting code. We're fighting chaos. And to fight chaos, you need a strategy. You need the right weapons in your arsenal.
Our first, and honestly, our most fundamental weapon is the concept of objects. And this isn't just some programming technique. It's a completely different way of thinking about your code.
Everything starts with something called a class. And I want you to think of a class not as code, but as a blueprint. Yeah, a blueprint. It's a detailed plan for something you want to build. It defines all the properties and all the capabilities of that thing, but it's not the thing itself.
A really great way to think about this is the cookie cutter analogy. The class is the cookie cutter. It defines the shape, the pattern, all of it. The object, well, that's the cookie itself. You use that same cutter to stamp out as many individual cookies as you want. Each cookie is its own separate object, but they all share the same structure from that original blueprint.
And this brings us to the real magic of objects: encapsulation. See, each object manages its own business. It hides all its internal, messy details from the rest of the world, and all you have to interact with is a clean, simple interface. You're basically putting a piece of that chaos into a cage, making it totally manageable. Okay, so we've caged individual bits of chaos into these objects. But an application isn't just one object. It can be hundreds, all trying to work together. So how do we manage the chaos between the cages? This brings us to the very next level of the problem. If you just throw a bunch of objects together randomly, well, you've just created a newer, more complicated monster. You need a plan for how they're all going to interact.
And that's where design patterns come in. Now, these aren't snippets of code you can just copy and paste. They're more like high-level recipes, proven solutions to common problems that developers have been bumping into for decades. Think of them like training manuals that teach your objects how to cooperate effectively.
The philosophy behind pretty much all design patterns boils down to one powerful idea: find the part of your system that is most likely to change, right? Maybe it's how you calculate taxes or how you connect to a payment gateway. You take that one piece of logic that's always in flux and you encapsulate it. You put it in its own object, its own cage, so that the rest of your system is protected from that change. This famous line from the book that really started it all, Design Patterns, is the ultimate goal here. It means your code shouldn't depend on the messy, specific details of another object. No, it should only depend on a stable, predictable interface like a contract. This gives you the flexibility to swap out those messy details later without breaking the whole system.
Okay, so we've got objects to manage code, and we've got patterns to manage the objects. Let's zoom out one more level. How do we manage the entire project, especially when you're working with a team? Well, for that, we need tools.
First up is Git. If that code monster thrives on chaos, Git is the ultimate monster tamer for teams. It's a version control system. Think of it like a time machine for your project that lets you track every single change and merge work from multiple developers without it all descending into chaos. Next is Composer. Why build a cage from scratch when someone has already built a perfect one for you? Composer is a package manager for PHP. It lets you pull in high-quality, pre-built components from the community, saving you from reinventing the wheel and letting you, stand on the shoulders of giants.
And finally, our safety net, PHP Unit. This is a testing framework.
It lets you write automated tests that act like an early warning system. Every time you make a change, you can run your tests and instantly know if you broke something. It's how you stay confident that your monster isn't just sleeping, it's truly been tamed.
So, let's bring all these different pieces together. Taming the code monster isn't about finding a single magic bullet. It's about building a layered defense against chaos.
This is how we manage complexity at every single level. We use objects to organize the code itself. Then we use patterns to organize the relationships between those objects. And finally, we use professional tools like Git, Composer, and PHP Unit to organize the entire development process. Each layer builds on the last one, creating a robust, maintainable, and monster-free application.
And that leaves us with a final thought. The battle against complexity, it never really ends. The principles we've talked about here, organization, encapsulation, automation, they're timeless. But as technology evolves, new monsters are going to emerge. The exciting part is thinking about the new patterns, the new tools, and the new ideas that we'll have to create to face them. What do you think comes next?